My name is Tony Duarte, and I teach Spark courses. One of the things that I've noticed talking to new Spark programmers is that they tend to be very confused about exactly what an RDD is. And this really matters because RDDs are fundamental to programming with Spark. So I want to take a few moments today to explain what an RDD is. This is a typical instruction that you might have inside a Spark program that you create. What you're seeing here is an RDD data structure that presumably you created and filled with data. And you're doing some operation on it. In this case, you just happen to be doing a map operation and specifying some function. And it's returning back to you an RDD in your program. Well, what I want to do is focus on this RDD data structure and talk about exactly what it is. What you see here is your RDD data structure. And what you see is an array inside it. This array has references to partition objects. The idea here is that these partition objects are serializable and can be spread around the nodes in your cluster. So for example, if you had a 4-node cluster, these 4 partition objects could live on those 4 nodes, and you would be able to do operations across those 4 nodes using this RDD data object. You'll notice that each of these partition objects in turn references memory. The idea here is that your data is kept in RAM on the various nodes in your cluster, and that's where you do your operations by default. This is a simple diagram, but it actually has some pretty significant ramifications. For example, if you had, say, a 1,000 node cluster, and you only had 4 partitions, that means you would only be using 4 of the nodes on your cluster. So knowing the number of partitions that you've got associated with an RDD and controlling that actually turns out to be an important aspect of programming with Spark. In addition, if you had, say, a 1,000 node cluster and you had 1,000 partitions, that would usually be a good thing. But if you only had a small amount of data, say a few gigabytes, that means you'd have a little bit of data spread across your cluster and a lot of partitions, and the communication overhead might overwhelm any benefit that you'd get from parallelization. So understanding this is pretty fundamental to programming on Spark. So continuing to dig into what would happen if you actually ran that instruction, I'm showing here the RDD that you started with and showing that it has a map method associated with it. What the map method does is actually pretty straightforward. All that it does is it goes out and creates a new type of RDD called mapped RDD. This mapped RDD receives a couple of parameters that you pass to it. These 2 parameters are a reference to this RDD that created it. It also passes the function that you specified out to that new RDD. What you see over here is that there's a compute method inside that new RDD that's created. All that it does is it stores the fact that you asked for a map operation and stores your function also. So those don't actually get executed at all. They're simply stored inside this new RDD. In addition, there's a reference back to the creating RDD. This is actually significant because this actually is what's called lineage in Spark. The idea here is that if a node fails, there's this lineage tree that gets built in order to be able to recreate data that might have been lost when a node goes down. Okay, let's put this all together. So when you run that instruction up at the top of the screen, you start off with an RDD. It's got some data spread around the cluster in various partitions. You create a new mapped RDD. This simply stores the fact you want to do some operation and starts building this lineage tree in order to keep track of what operations were requested. The idea here is that at some point in the future, you'll be able to submit this to the scheduler for execution. And at that point in time, this map will actually get executed. It'll go out there and do operations in those various memory partitions. So this is just a basic concept of Spark, and important to understand. Of course, there's lots more we could talk about, like how you set the number of partitions, how you actually schedule this, and what actually happens when you actually execute this thing, how you control memory and memory considerations for when you're using this. But I hope this gives you at least a good start to programming with Spark. Thanks.